Also hand in lesson 1 if you haven't handed it in on momentum, or you get that done by the end of today, please, would be wonderful. What we're going to be using today, Jenna, is first of all the concept that momentum is mass times velocity, and that change in momentum can be written in two ways. It can be written as force times change in time, and it can be written as mass times change in velocity. Although typically, oh, that's a terrible vector symbol, Mr. Dewick. Typically, instead of writing m delta v, I usually write this as m v final minus m v initial, because change in is final minus initial. That's all on your green sheet. So, example 1 says this: a force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. A says, what's the magnitude of the object's change in momentum? What's this question asking me to find? Change in momentum. Another word for which is? Okay, so the first thing that I would probably do is I would say it wants me to find that. The tricky part with impulse is I have so many different ways to find it. One way, don't write this down, one way would be to go m v final minus m v initial. Don't write that down. Did they give me a final and an initial velocity? No. What did they give me in this question? And a? So that's my hint that I'm going to use this version of impulse. And the reason I said magnitude, because impulse is a vector, but I didn't give you any directions, so I'm just saying, how big? Patrick, how big is the force?
8 newtons.
How big is the time? In your head, without doing any calculator work, impulse is 80 units. You could say kilogram meters per second, because that's momentum impulse. Because I used force times time, probably I would write Newton times seconds, but if you wrote kilogram meters per second, I'd give you full marks for that, no problem. Okay. B says, what's the magnitude of the object's impulse? It's meant to be really easy. Linnea, I'm asking, do you know that change in momentum and impulse are the same thing? We just found the change in momentum, we just found the impulse. So the impulse, which is also written as delta P, is 80 Newton seconds. By the way, it's Newton seconds, not newtons per second, because per second would be on the second would be on the bottom. It's Newton times seconds. I put a dot between them just because that way you can tell they're two separate units. I don't know. That's the times dot. Okay. What does part C want me to find? Change in velocity. What did I find in part B and part A? Impulse. I wonder if I have another version of impulse that has a change in velocity in it. I think I do from the green sheet. I think one of the ways I also wrote it was, is m delta v is also on there? Yes? Okay, how would I get the change in velocity by itself? Yep. So, the change in velocity is going to be the impulse divided by the mass, which is going to be 80 divided by, well, I've scrolled down. What was the mass? 4? Hey, in your heads, folks, 80 divided by 4. 20 meters per second. That's the change in velocity. Now here's what that means. Lyndon, if you were originally going 1 meter per second, your final velocity was 21 meters per second because your change in was 20. If you're originally going 40 meters per second, your final velocity was 60 meters per second because your change in was 20. Or D, if the final velocity was 12 meters per second north, what was its initial velocity? What did we find in part C? What's change in anything? So here's what I would write down. The change in velocity that we just found is equal to V final minus V initial. Taylor, you okay with that? Taylor, what's D asking me to find? Yeah, and now we're finding VI differently from the beginning of the year when we were going VF equals VI plus AT and VF squared equals VI squared, all those ones. Now we're doing this in terms of impulse and momentum. We have a whole bunch of different tools at our disposal. I want to get the VI by itself. Taylor, what's right in front of the VI that I don't like? Hey, wait a minute, we've done this dance before. Remember the little swappy dance? I'm going to plus the VI to that side. At the same time, I'm going to minus the delta V to this side. You okay with that, Darce? I think I'm going to get this. The VI equals VF minus delta V. Taylor, what's V final? Read part D carefully. What's V final? Okay. Say it again, not to make fun of you for a reason. What's V final? Do you notice he said 12? What direction has he just decided is going to be positive? North. Because you said positive 12. You didn't say the word positive, you said 12. So if I get a positive answer, I'll write north. If I get a negative answer, I will call that okay. Because it's going to be 12 minus, what was the change in velocity? And I get negative 8 meters per second north. Or, how would we really write that? You were going backwards, south, 8 meters per second. Your impulse, a force was applied to you, and your final velocity was 12 meters per second for a change in velocity of 20. 12 meters per second north. Okay? A snow scooter has a mass of 350 kilograms. A constant force acts on it for 60 seconds. The snow scooter's initial velocity is 2.5 meters per second, and its final velocity is 18 meters per second. The fact that they gave me an initial and a final velocity, I'm already thinking, Sydney, I'm leaning towards a certain way if they start talking about impulse. I don't think I'm going to be going force times change in time. Did they give me a force? No. They did give me a time. In fact, what are they asking me to find in part B, Sydney? Part B. You know what? That's when I'll bring in the force change in time. What are they asking me to find in part A? I got to be fussy, not momentum. Oh, impulse. Okay. So, change in momentum is, I think here, I'm going to think to myself, don't write this down, M change in velocity. But instead of writing it that way, what's change in anything? So, I'm going to write that as M V final minus M V initial. I went with that one because I clearly saw they've given me a final and initial velocity. Sydney, what's the mass? What's V final? Yep. Minus, you said the mass was 350. What's V initial? 2.5. I don't have a direction here. I really should have said what's the magnitude of the change in momentum, but okay. What is 350 times 18 minus 350 times 2.5? Now you probably need your calculator. You get 5,425? Yeah. Units, Sydney. Ready? What do I measure mass in? What do I measure velocity in? You could also have said Newton seconds, and I would give you full marks, but since I didn't use the force times time one, that was not what was in my brain. What was in my brain was the mass times velocity unit version of momentum. Is that okay? Cool. Connor, what does B want me to find? Force, you say. What did we find in part A? Is there an equation that has impulse and force? Is there a way to write impulse and force? Oh, now I think I'm going to go to this version of impulse from my green sheet. Force delta T. Connor, how would I get the F by itself? How do I move the delta T over? Yep. Another way to write force. I think I told you the other day, Newton never actually said F equals ma. He actually said force is impulse over time. That was what he was interested in. But that simplifies to F equals ma. What was the impulse? 5,425. I've scrolled down, Connor. I think they told me the time originally in the question somewhere. Did they not?
60 seconds.
Yeah. So for a whole minute. If you push on something for 60 seconds, I don't think you need to apply a big force to create an impulse. I suspect the force isn't going to be very big. You get 90.4 newtons. And this is one of the key ideas, Gurjot, in car accident safety. If I make time bigger, if this value gets bigger, and I'm stuck with the same impulse, but if I can make this bigger, what happens to the force? It gets smaller. So if I can lengthen the time of a collision in a car accident, I can dramatically reduce the force that's transferred to the driver. Seatbelts and crumple zones, that's what they're designed for. Crumple zones in cars are designed to lengthen the time of collision. And again, the nice thing is, Daniela, in a car crash, the time is so small, it's not that hard to engineer your car to double that time. So in a car crash, the time might normally be 0.02 seconds. It's not that hard to get that up to 0.04 seconds with crumple zones, but I've just cut the force in half. Basically, I've doubled my survival expectancy just by doing that. Some good engineering going on into cars. I had a 1969 Mercury Meteor for a while growing up. Big car, we fit 39 people into it one time just to see if we could. We were trying to get 43 because that's what a school bus held, but we got 39, it's pretty good. Cars back then were designed to be indestructible. If my car got into a fender bender, nothing would have changed. No dents, no change to the car would have been fine. The problem with that thinking, Darcy, is the impulse, the force, all gets transferred to the occupants, to the drivers. And it really wasn't until the late 70s and 80s where car companies realized people would much rather have their car be damaged badly and walk away from the crash than the other way around. It's really only been in the last couple of decades that car safety has become a big priority. Car companies realized people will pay extra for car safety. Airbags and side impact airbags and all that stuff. Okay. A rocket of mass blah, 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 starting from rest, I would probably underline starting from rest, is acted upon by a net force of blah, blah, blah for 120 seconds. What's the final velocity of the rocket? You could do this already without using momentum or impulse. It would be about 5 steps. But using momentum and impulse, we can do this in a couple of lines. Really? Yeah. Brian, what's this question you want me to find? Okay. Force, see it? Time, see it? That's impulse. Brian, what's this question asking me to find? MV final minus MV initial, because impulse is momentum and change is change in momentum, and change in anything is final minus initial. By the way, if I'm doing my job right, you should start to notice, Darcy, I'm just going in circles and rewriting impulse in all the different ways and saying, how can I mix and match and combine it? Brian, what do you say this wanted me to find? What's the initial velocity? So because of that, I can cross that off. If not, I would plus that over to the other side. But the fact that it's 0, yay, I can cross it off. Brian, how would I get the V final by itself? Yeah. It's going to be the force times the time divided by the m. Force, 2.3 times 10 to the 4. Time, 120 seconds, divided by the mass, 2.6 times 10 to the 4th. Hey, wait a minute, don't need brackets. Bracket around the top. 2.3 times 10 to the 4th times 120 divided by, it's only one thing on the bottom. You get 106 point, well, I'll call it 106. Yeah? Brian, units? Yep, not kilogram meters per second. We found a velocity this time. This right here explains most of rocket science. So you ready, Brian? I'm going to ask you a question. In particular, rather than looking at the numbers, let's look at this little line right here. What if my rocket has more mass? What's going to happen to my final velocity? Bigger, smaller, or stays the same? If this bottom number gets bigger, and I'm stuck with the same engine, and I burn it for the same time, so my force and my time don't change, what happens if you divide by a bigger number? What happens to your answer? Bigger, smaller, huh? Yeah. So what does NASA do? Make the rockets as light as possible. There. If I want to get more speed, got to lose some weight. If any of you saw the movie The Martian, the ending scene there where he takes the spaceship and he strips it of everything possible, that's all because he's stuck with the same impulse. He wants a much bigger V final. Better get rid of some mass. It's the only way to do it. A car of mass 1,600 kilogram moves at 32 meters per second. What braking force is needed to bring the car to a halt in 1.6 seconds? Again, by the way, see here, we could have, since we knew the force and we knew the mass, we could have found the acceleration, F equals ma. And since we know the acceleration, we could have gone Vf equals Vi plus At, and then we could have solved for Vf equals Vi plus At. We know Vi was 0, A we found from the force, T they gave us. The nice thing about impulse is it really lets you do all of that in one combined line. It's a win. It's a shortcut. Same thing here. It says what braking force. I could probably find the acceleration. They told me the mass, and I could go F equals ma. Or, with a little bit of cleverness, I can do this, Luke, all in one fell swoop by using impulse. Luke, what do they want me to find here? Did they give me a time? Did they give me some different velocities? I'm going to use impulse. I'm going to say, okay, impulse equals impulse. All from that single three-line equation, three-term equation on your green sheet. What did this want me to find? Oh, sorry, hang on, let's stop for a second. Are any of these 0? So, because of that, if it wasn't, okay, no problem, but yay. How would I get the force by itself, Luke? So the force is going to be negative mv initial divided by time. Delta t, but there's always a delta in front of t, so we get lazy and sometimes just don't bother writing it. Negative 1,600 times 32 divided by 1.6. Oh, this will work out nice, I think. Do you get negative 32,000? Or am I wrong? Negative 32,000? What's the negative? Well, first of all, let's read it. Negative 32,000. Luke, units, force? Force. Newtons, right? What's the negative telling me? The negative is telling me that the force has to be in the opposite direction of the final velocity. Which makes sense. If you want to stop, if you're going forwards, which way do the brakes push? Backwards. Okay? So I'd leave the negative here. There's no real way to give me a direction because I didn't tell you whether we're traveling north, south, east, or west or anything, but I'd leave the negative backwards. Sure. A rock falls from the top of a 40-meter high building and strikes the ground below. What's the force, magnitude, and direction of the ground acting on the rock if it comes to a stop in 3.5 seconds? Comes to a stop. They want the force. You know what? This is, I think, almost the same equation. Almost. I think it's going to be force times change in time equals mv final minus mv initial. Mobeen, what's the final velocity? Oh, so nicely I can do this. In fact, we get the same line as Luke gave us just a few minutes ago. We get negative mv initial divided by time. Mobeen, did they tell me the time of impact? Read very carefully. Did they tell me the time of impact? Yeah, see the seconds there? Did they tell me the mass of the rock? Did they tell me the initial velocity that we hit the ground at? So even though this question is saying find the force, you know what I'm going to spend most of my time finding? The velocity. Let's draw a little line. Let's make a little note. We need VI. What haven't I used yet? Taylor? Which did? Oh, that 40? Hey! This is free fall. We spent a whole unit looking at free fall. Okay. Now, VI, this is going to be VF at the bottom of the drop. VI, once you hit the ground, is VF at the bottom of your free fall. So I'm going to find V final in free fall, which is going to be V initial at the beginning of the collision, beginning of hitting the ground. Is that okay? Show you what I mean. I think I would say this. How far are we falling? 40 meters? Did I say falling? I won't write 40. What will I write instead? Negative 40, right? Oh, I know this. Got to be careful. Now we have to put the negatives back in, right? Falls from the top. I know V initial, if it just falls off of the building, must have been 0, and I can find V final when it hits the ground. This is good review. We're almost towards the end of the year. This stuff will be on your final exam. I'm looking for an equation that has a D, an A, a VI, and a VF in it. Which one? Wow, the cobwebs are coming off the brains. We're brushing off the cobwebs. Mike, say that again. Yeah. Oh, and Mike, I can do that because VI is 0. Okay. Now you got to be careful. We're using VI differently over on the left-hand side. VI on the left-hand side of my momentum equation is the impact initial velocity, which is going to be VF on the right-hand side. We've done a few like this before, where our final became an initial when we moved to the next step. How to get rid of the squared? Okay, so VF is going to be the square root of 2 times negative 9.8 times negative 40, not 20, Mr. Dewick, 40. 2 times negative 9.8 times negative 40, square root of that. Oh, holy smokes, works out evenly. Why is 28 meters per second technically wrong? Yeah, remember that we ran into this way back when you take the square root, your calculator will always assume that you want the positive answer. But there's always also a negative answer when you take the square root. Your calculator gives you the positive one. I think in this case, we are definitely hitting the ground traveling downwards. Lyndon, I would argue in this case, it's definitely negative. And that V final is that V initial. Because now we're looking at the impact after it's hit the ground. We're going to get F equals negative 2.5 negative 28 divided by 0.35. Mobeen, coming back to you, is that okay? And you'll notice here I get a negative times a negative. Mobeen, what's a negative times a negative? I'm going to get a positive. Now, ready? This negative meant down. The fact that I get a positive force, what direction is the force? Yep. Which makes sense if you've ever fallen and hit the ground. I assure you, you felt the force up on your body when you hit the ground. Okay? But there's a lovely algebraic proof. I'm going to get negative 2.5 times negative 28 divided by 0.35. Holy smokes, this worked out evenly. Is it 200? Yeah. F equals 200 newtons. And it did say magnitude and direction in brackets next to the force. What direction did you say the force was, Mobeen? There you go. I would argue so far I haven't taught you a single thing new. Just mixing and matching and being clever. I like example 6, I like example 6, I like example 6. Example 6 is a nice question. So a ball moving at 4.65 meters per second east hits a wall. The wall exerts on a force on the ball, 350 newtons to the west for 0.0750 seconds. Find the final velocity, magnitude, and direction of the ball. There's a collision, there's a force, there's a time. This is a job for impulse. Darcy, you gonna make it? It's a long blink. You okay? What does this want me to find, Darcy? Of what? Of what? What does it want me to find? VF. Okay. Again, you could probably, with some cleverness, because they've given you forces and things, you could find the acceleration and you could use VF equals VI plus, we can do the whole thing in one fell swoop. I think we can say force times change in time. I wrote that because I saw that there was a force and a time. Equals mv final minus mv initial. Impulse equals impulse. Change in momentum equals change in momentum. Are any of these velocities zero this time? Nope. So this time nothing's going to cancel. Darce, what did you say we want to get by itself? Yeah. Okay. I'll put a little red dot above it. I guess the first thing that I want to do is I want to move this over. How would I move a minus mvi over? Oh, so you're telling me f delta t plus m VI, vector on the velocity, vector on the force. That equals, don't write this next bit down, Darcy, just imagine it. Look, 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 look. MV final. What did you say I'm trying to get by itself? How would I get the M over? Okay, so let's write this down. Yep. Yet another equation, Thomas. Please don't memorize it. We can derive it with our skills now. Have I sold you on why it's so much better to do it that way than to try and memorize all these combinations? I still remember I had one kid about 8 years ago, right around November, she broke down. She was trying to memorize every single one and just gave up after a while. Okay. Pardon me? Oh, she got an A. She had memorized her way to 100% her entire high school career, and she'd even I never had her for Physics 11. So she pulled it off in Physics 11, but in Physics 12, about November, okay, Mr. Dewick, you're right. I need to learn how to rewrite these because yeah. Also, by the way, being able to rewrite them lets you see how they all work together. Remember a few minutes ago I asked you in the rocket equation, well, what happens if I have a bigger mass? I won't go as fast. I better lighten up if I want to go faster. All right. Darcy, you ready? What's the force? 350? What's the time? I'm not going to put the 0 on the 0.075, right? Plus, what's the mass? Are you ready? The initial velocity can't be 4.65. Can anybody see why the initial velocity can't possibly be 4.65? Okay, you ready? With your pen or pencil, everybody underline the word east, underline the word west. What did you tell me the force was, Darcy? Look up. What did you tell me the force was? Did you say positive or negative? You implied positive. So what direction did you decide would be positive when you said that? So why can't I call this 4.65? Because it is. So what will I have to say instead? That's a very subtle mistake. That's why I like this question, I like this question, I like this question, and I'll catch a lot of people in that mistake. So I would even, now I might let east be positive and west be negative, because that's kind of how I think, but you decided I would actually over here put a little W and a positive next to it, put a little east and a minus next to it, and maybe even do like a little compass rose, just to remind myself that's what you decided now. So, you with me? And it'll make a big difference to your final answer. If you wrap your brain around that part, then, Taylor, it's plug and chug. But catching the directional changes, have I said that vectors are going to be much more important? There's going to be changes in directions, and that's my rant right there. Divided by, what was the mass again? Is this a fraction? Yeah. Is there more than one thing on the top? Yeah. You better put brackets around the top. I don't know whether if I get a negative answer for my velocity, what direction? If I get a positive answer, yeah. Do you get positive 10.9? Yeah? No? Am I wrong? Oh, you know what? Hang on. I typed this wrong. I put a minus sign there in front of the 4.2. It's plus 4.2. That was my bad. Typo. The 1.6? Hey. Units, meters per second. Direction. Linnea, if you wanted to do this same question, but you decided, because you noticed the directional changes right away, and by the way, one of the things you want to see is if they give you compass directions, a little alarm bell should ring. There's probably going to be a change in direction. If you decide to let east be positive and west be negative for the whole question, you would have let the 350 be negative, you would let the 4.65 be positive, and you would have got negative 1.6, which you had called west, and that'd be perfectly fine. You'll get the same answer. There's no right or wrong way to do it, whatever way makes you happier. Okay? A rifle accelerates 12-gram bullets from rest to 250 meters per second. The rifle barrel is about 0.85 meters long. A says, find the impulse acting upon the bullet. And then B says, find the force on the bullet. And Mr. Duick says, wow, I didn't leave anywhere near enough space. What happened there? Why did I not leave more space, Mr. Duick? Okay. Well, we can do A if we write small. Tristan, what does A want me to find? First thing I'm going to do is write down my delta P, that's impulse. Now I got to plan my strategy. Am I going to use force times time? No. You know how I know? I glanced at part B already, and the fact that they were asking me to find the force, I said, nope, can't use that. So I'm going to try the other one, which is mv final minus mv initial. I did a quick check. They did give me a mass, yes, and they gave me a final and an initial velocity. Bada bing. What's the mass, Tristan? 12 what? We don't do mass with grams. How do I go from grams to kilograms? Ready? Listen close. How do I go from grams to kilograms? Kilo, that's 1,000. Divide by 1,000. Some of you can probably do it in your head. Double check me. I think you get 0.012. That's 12 grams. Tristan, V final? Yep. What's V initial, by the way? So, you know, if I was really clever, I could have done that and crossed out the minus MVI. I think I could do that in my head. 3? Or 30? 3. 3, and you could write, Tristan, kilogram meters per second, because we used mass times velocity. Again, if you wrote Newton seconds, I'd give you full marks. It's just not what I thought in my brain. B, what does it want us to find? Yeah. So I would go like this. Impulse equals force times time. Even though this question wants me to find force, you know what I'm going to spend most of my, here's your hint, you know what I'm going to spend most of my time finding? Time. How would I do that? I didn't give you enough room, and unfortunately we can't finish, but here, let's make a little note. Find T, and then we'll draw a little arrow. VI was 0, VF was 2.5, D was 0.85. We could find T. I think we'd use the one that has the 1/2 D equals 1/2 bracket VI plus VF times T. The one we hardly ever used. We could, but I don't have room to fit it in. I don't know what happened here. I think somehow the spacing changed. Sorry. All right. Says, consider the diagram at the right for the next 3 questions. The final diagram depicts the initial and final velocities of an 800 kilogram car in 2 different collisions with the wall. So in the first situation, the car rebounds off of the wall and goes back in the opposite direction at 4 meters per second. In case B, the car comes to a stop. First question, in which case does the car experience the biggest momentum change? Case A, case B, both the same, or I need more info? What do you think? You know what? Once again, this is a chance for us to vote. How high you hold your hand up is how sure you are of the answer. So we have case A, where the car hits the wall and bounces off in the opposite direction. Case B, where the car comes to a complete stop. Which one experiences the bigger impulse? Case A, case B, both the same, or can't tell? Who says, Mr. Dewick, A, Mr. Dewick, A? 1, 2, 3, 4. Who says B, Mr. Dewick, B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who says C? Both the same car. Who says D? You need more info. Let's see if we can figure this out. I think to analyze this, the version of impulse that I'm going to use is the one with the final and initial velocities, the change in velocities from the picture. So really, which situation has the biggest change in velocity magnitude? Because the mass is the same for both of them. What's change in anything? Final minus initial? What's the change in velocity here? No, it's not 1. It's 9, because you have to let one way be positive and one way be negative. You could call it negative 9, you could call it positive 9, but I'm telling you the magnitude of the change in velocity there is 9. What's the magnitude of the change in velocity here? 5. So which one delivered a bigger change in velocity, A or B? Which one delivered a bigger impulse, A or B? It's a much more it's a way worse collision if you get knocked backwards during the collision. You have undergone a way bigger force, a way bigger impulse. You're going to be in way bigger damage to the pedestrian, to the occupant, to the passenger, not pedestrian, to the passenger. Okay? Case A, because larger delta V. Those of you that voted for case B, have I convinced you? Yeah? Okay. Question 2, which car experiences the greatest impulse? Kieran. I think you said it. It's all right. Kieran sitting, did it again. Harshpreet. A, because impulse and change momentum is the same thing, right? Stupid brain. The impulse encountered by the 800 kilogram car in case A has a magnitude of what? Okay, now they've given me a mass. So now I can say the impulse is equal to m change in velocity. What did you tell me the change in velocity in case A was? -9, +9, depends which way you let be positive, which way you let be negative. I'll make it positive because I'm better with positives. What's the mass? 800. What's the impulse? A, B, C, D, or E? Or F? E, right? Okay? So in a collision, it's better to come to a stop than to be knocked backwards if you're in a car crash. Which type of collision is worse for a passenger? Assume the initial velocities and the time of impact are the same in each situation. Which type of collision is worse? A head-on collision where the two cars stick together? A head-on collision where the two cars rebound apart on impact? What do you think? Connor, take a guess.
Well, from what we just saw.
Yeah, what? From what we just saw, what?
They're rebound, so that's worse.
Yeah. Why? larger. Can I insert a delta? Okay. Oh, symbol. Show me a delta. More symbols. You know what? I'll have to handwrite it with my messy handwriting. Larger change in velocity. Yeah. This impulse equation, I've told you earlier, last lesson, is really handy in analyzing collisions, and we're really starting to understand why certain car crashes are bad, why certain car crashes are not as bad, why do people survive or come out unscathed in certain situations. The really bad ones would be a massive locomotive hitting a tiny car. The locomotive will hardly have any change in velocity. It's going to keep going straight ahead, but that little car is going to have a massive change in velocity, a massive impulse, and since impulse is force times time, massive force transmitted to the occupants. Last question. The diagram below depicts the changes in velocity of a ball that undergoes a collision with the wall. Indicate which case, A or B, has the greatest change in velocity. Let's calculate it. What's change in anything, Patrick? What's the final velocity of B? What's the initial velocity of B? Don't say 30. What's the change in velocity of B? 5 minus negative 10. What's the change in velocity of A? There's our proof. B. Explanation, we calculated it. Which one will have the biggest acceleration? So now we go back to the very beginning of the year, and I told you that acceleration was defined as change in velocity over time. You know which one's going to have the biggest acceleration? The one that has the biggest change in velocity. So, answer? B. Which one's going to have the biggest impulse? B, because the biggest change in velocity, same mass. Which one's going to have the biggest force times change in time? Isn't that just another way to write impulse? B. If the time of impact was the same, which one underwent the biggest force? B, because the only way you can get that big an impulse with the same amount of time is to apply bigger force. Got a video in a second, but what's your homework? I think I'm going to... Ooh, that's a lot. Ooh, that's a lot. Okay, let's pick and choose a little bit here. One is good. 2 is good. 3 is good. 4 is good. Yeah, we'll do every question for this. 5 is good. 6 is good. 7 is good. 8 is good. 9 is good. 10 is good. 11 is good. And I stuck all the answers at the bottom there. "12 is good. 13 is good. 14 will skip 15. Yeah, 16 I'll pass on. It's cool but nasty. 17, water skiing is fun. 18. I'll skip 19. 20 is good. Yeah, let's do Calvin and Hobbes. 21. 22. 23. I've given you an awful lot. I'll give you extra time to work on this video to show you too.